is very short. In the course of political events and other things, it's a long time. But for us in the scientific community, 5 years is a very short amount of time. So we still really don't know what the long-term impacts are.
You asked a question about fisheries, and I'm the fish guy here, so let me just comment on that. Yes, there are impacts on the fisheries. Some of the fisheries, say in the Barataria Bay, are still closed for direct harvest because of the substantial amount of oil located up in those marshes. As well, we know that the animals are continuing to be exposed, and you saw some of the results we've had. And also, in terms of actually monitoring, the impacts on fisheries, the time frame that we're talking about is consistent with other major spills. For example, in the Exxon Valdez incident, it wasn't until about 5 years that we recognized the collapse of the Prince William Sound herring populations, which are a keystone in that ecosystem as well. And so the kinds of things that we would look at in terms of significant effects take time to work themselves out, and that's actually where we are right now. Any other questions? Sir?
To what do you folks attribute the industry's attachment or favoritism toward dispersants?
Want to try that, Dr. Hollander?
Sure. Dispersants essentially are a mechanism to bring it out of sight. Dispersants will do two things. Dispersants will decrease the droplet size of oil, and it will also make some portions of oil more soluble, both of which have the capacity to bring it out of the surface. So it's inherently a very favorable position to take to bring it out of the public's eye. In the case of the Deepwater Horizon, there was the application of dispersants in two very distinct modes. One was at the surface, and one was at the subsurface. The analysis of waters directly after the start of the blowout and the recognition of the subsurface plumes occurred prior to the application of subsurface dispersants. The role that subsurface dispersants can play can perhaps enhance the amount of oil in the plumes, but that has not been tested. It was applied in the subsurface without an environmental test of its effectiveness and efficiency, and that's why the experimental work is really quite critical to having a real test. The only alternative is to wait for the next blowout and to apply it. We are still searching for real-time data from the industry and from agencies to the effectiveness and efficiency, and that has been not very forthcoming. The other application of the dispersants is at the surface. Remember, the dispersants is a solvent, and it has a component of surfactant and a component of solvent. The solvent will attack the oil. The surfactant will allow it to more readily interact with the water. The application of the dispersant at the surface essentially was able to decrease the droplet size and to break it up. And you saw this red mousse type material, which is oftentimes associated with the application of the dispersants. It also caused a portion of the insoluble droplets to become more soluble and bind with the water. But that had a really unexpected consequence, especially in association with the other surface oil spill responses. There was the burning of the oil, of which a portion goes into the atmosphere as aerosols, but actually can fall back down to the ocean surface. Another part of that burning leaves a residual component of the oil behind. It's not 100% efficient. Some people say 70, some people say 90% efficient. But a portion of that material is left as residual. What's interesting about the burning, of course, is that the burning produces what they call a unique set of these PAHs, these polycyclic aromatic hydrocarbons, that are called pyrogenic PAHs, and they can be quite carcinogenic for long periods of time. The third response strategy was the opening up of the Mississippi to push the waters out of the marshes, out of the sensitive coastal ecosystems, the wetlands, the marshes, and to try to push the oil offshore. With those opening up of the Mississippi, Louisiana has been trying to build their marshes back, to build up their marshes over the last decade. And part of that has been to try to trap clays, minerals, and sediments in those marshes to help them build back. But when they opened up the diversionary channels, when they opened up the main stem of the Mississippi, the energy was high enough to begin to push those stored clay minerals back out to the offshore. And associated with those were nutrients as well. So with the fresh water pushing the oil offshore came clay minerals, clay-sized minerals, as well as nutrients. And so the scenario goes is that those clay minerals and those finer droplets that were acted upon by the dispersant have an incredible affinity for each other. It's a well-known process called oil mineral aggregation, or OMAs. Associated with the nutrients were algal, bacterial material or populations that would bloom in the presence of excess nutrients. But with those blooming algae was oil and dispersants, which are contaminant. And in the presence of oil and dispersants, the algae produce this very slimy mucilaginous material to try to protect their cell walls, their cell membranes from the contaminants. That sticky that mucilaginous material is extremely sticky. And so the oil mineral aggregates, the algae, the dead debris, all aggregated and flocculated together, but with the clay minerals was able to settle out of the water column very quickly. Oftentimes, typical particles will settle at 10 meters a day, 30 meters a day. This material was able to settle at hundreds of meters per day. In other words, it would almost, from the environmental point of view, instantaneously settle to the bottom. And so the dispersants had their effect that perhaps the industry wanted, but there was many unexpected consequences as a result of that. And so these trade-offs now have to be put into a context of priority from society. And because they do have a location impact to a part of an ecosystem, there is now a financial evaluation that comes with that as well. And that's part of the trade-off that will have to be assessed.
Your research could conceivably conclude that the use of dispersants, as it was 5 years ago, may be more detrimental than not using it at all.
I think in particular parts of the ecosystem, if they are prioritized, yes. If they are lower priority, perhaps that's still a strategy that should be adopted. It's clear that the deep ocean benthos, perhaps all would agree, has a lower priority than the marshes, where you have birds, where you can have coastal organisms like turtles. These are animals that blink, and no one wants to see a bird covered with oil. It's terrible public relations, and I think society has a real problem accepting that. It may be more tolerable.
Dana, do you want to talk about the toxicology-related issues of dispersants?
Well, I just want to, David makes a whole host of great points. And I'll just say, I'm very happy that I have never had to make that decision of when to use a dispersant. I'm not, because it is difficult. But if you're thinking about or visualizing all of the oil that was being pumped out during that spill, during that blowout, and it was migrating towards the Louisiana marshes and the Florida beaches, those areas in particular in Louisiana are highly productive areas. Those are nurseries, those are habitats, those are very sensitive. By applying dispersants, they're trying to keep that surface slick, which was very thick and moving quite rapidly, from oiling the marshland. Picture back at the Exxon Valdez time, right? And those, even though those little islands weren't quite as important nursery grounds perhaps as arguably Louisiana's are, you know, that oil got up on those beaches, is still present. I have oil over there in jars that was collected from Prince William Sound from February of 2014. It's still present. So it's a trade-off, yes. What I have noted in some of my work with toxicology or looking at the toxicity of dispersants, and I've looked at mainly Corexit 9500, a little bit with Corexit 9527. And the comparative toxicity is extremely different between oil and dispersant. Dispersant, in my opinion, is not nearly, it's orders of magnitude less toxic than oil. The combination of oil with dispersant, that increases the toxicity significantly. But dispersant is like soap. So if you get, you know, grease on your hands or olive oil on your hands and you want to get it off, you wash your hands in soap. The soap's cloudy because it has now taken the polar and nonpolar components of each of those surfactants and the oil, and it is now all soluble in the water. So that's why you get that kind of orangey color. It's a trade-off. But I can understand some of the reasons of why you would apply it to the surface. I still question the mile deep application of the dispersant. I think that was a hope that something good would happen, but I don't think we were really sure exactly what the outcome was going to be.
Maybe I can mention one more point. The discovery that this process of flocculation and sedimentation is the discovery of a new process in association with these kind of events. Traditionally, you would apply dispersants and open up the floodgates and have this material go into the offshore region, dissipate into the offshore region, be eaten by microbes, and not have a terminal fate. The fact that we've been able to discover that there actually is a focusing of this material down to the bottom now presents it as a trade-off that needs to be taken into consideration and evaluated from an ecosystem point of view, which ultimately has an economic point of view.
Thank you. If there's one more question, we'll take that.
We have afterwards demonstrations outside to exhibit the news during the oil spill. We give tours on the boat of the vessel as well. And everybody's available for one-on-one interviews either in here or outside where other people are.
As well, the students are available, and as well some of the other researchers in the consortium. So with that, I'd like to thank you all for participating in this news conference. I hope it's been informative to you all. And again, I want to thank all the speakers and certainly the leadership for their wonderful remarks. And thank you all for participating.